Hello everyone. So in this video we will be building a transparent lottery system on the Rootstock. So before diving it, we will first understand what is Rootstock. So Rootstock is the first and most established Bitcoin sidechain offering a groundbreaking layer 2 solution that combines Bitcoin's unmatched proof of work security with Ethereum smart contract capabilities. It is fully open source and EVM compatible. Rootstock enables developers to build and deploy decentralized application dApps seamlessly while leveraging the strength and decentralization of Bitcoin's network. It is secured by over 60% of Bitcoin's hashing power through merged mining. Rootstock ensures a high level of security and trustlessness for its user. This innovative platform acts as a bridge expanding Bitcoin's functionality beyond simple transaction to power use cases such as DeFi, tokenization, and identify management. With its commitment to scalability, interoperability, and decentralization, so Rootstock is a forefront of enabling a vibrant ecosystem of dApps, fostering innovation while staying anchored to Bitcoin secure and decentralized infrastructure. So now that you have got a quick overview of Rootstock, so let's jump into understanding what is exactly the lottery system we are building. So we are going to build a decentralized lottery system. So we will be building a decentralized lottery on the Rootstock platform, allowing users to participate in a fair and transparent lottery system. So our lottery will leverage the power of smart contracts to automate the selection process and ensure trust among participants without the need for intermediaries. So let's understand few of the key features of our lottery system. So first one is like player entry. So users will be able to enter the lottery system by sending a small amount of RBTC, like minimum 0.0001 RBTC, and for each entry increases their chances of winning the entire prize pool. Second one is a random winner selection. Lottery manager can trigger a random winner selection process using blockchain based randomness, ensuring fairness and transparency in the selection. Third one is prize claiming. So winners can claim their prize directly from the smart contract with the entire pool automatically transferred to their wallet. Fourth one, real-time updates. So players can view the current lottery status, number of participants, and see if the lottery round is complete. Sixth one is transparency and security. By utilizing Rootstock blockchain technology, all lottery entries and winner selection are rounded on a secure and immutable ledger, providing complete transparency for all participants. And the last one is like user friendly interface. So we will be creating a user friendly interface using React, making it easy for users to enter the lottery, check the status, and claim the prizes. So in this video, you will be building a fully functional decentralized lottery that showcases the capabilities of smart contract on the Rootstock platform. So the steps would be like, first we will be writing the smart contract, then we will be deploying the smart contract, then we will be verifying the smart contract, then we will be writing the front end with all the integration of the smart contract, ABS, contract address, and finally we will be playing with our smart contract. So now we will be setting up the basic environment for our project. So if you don't have MetaMask installed, simply search for the MetaMask. So from here you can download the MetaMask as an your extension and set up your wallet. So as I have already installed and set up, you simply need to pin it. So you can pin it from the extension part. Then you need to add the Rootstock network. So you can add it from your Rootstock website. So from simply here, you can configure your MetaMask for Rootstock. You can also follow this guide from the Rootstock official docs and add the necessary Rootstock mainnet and Rootstock testnet to your MetaMask based on your requirement. Or also you can add by using chain list. So simply search for chain list.o, and here just select the include testnet and search for Rootstock. From here you simply need to add the MetaMask if you want to connect mainnet, and click on the add to MetaMask if you want to add the Rootstock testnet. So for deploying the smart contract on Rootstock, we will be needing few of the tokens of RBTC. So we simply need to grab it from the faucet. So simply search for faucet.rootstock.io, and here you need to enter your wallet address, and also you need to confirm that you are not the robot, and you simply need to click on the get RBTC. So from here you will be getting the RBTC TRBTC, so which is the token for deploying needed to deploy the smart contract on Rootstock. So our transaction is getting complete. So as it is saying, you will be need wait about 30 seconds while the transaction is been mint. So once mint, our tokens will be added to the address what we have entered. So you can simply see that the tokens has been sent. Also we can verify it from the explorer. So the transaction has happened 20 seconds ago and the status is success, and the transfer of token has been taken place. So now we will be start with writing the contract needed. So we will simply go to the remix ID. Here we need to go to the online ID. So here we will be creating a file name lottery.sol. So now we will be writing the contract for the same. So first we will be including the license that we will be needing. So here we will be using the MIT license. So the command would be spdx dash license identifier. Now we will be using the Solidity version from above the 0.8.0. So the command would be pragma solidity and the caret symbol 0.8.0. So now we will be naming our contract as name lottery, and here we will be defining few of the const that we will be needing. So first one would be the manager with data type as address, and it would be like public. Second one would be the array. Let's make its address payable. It would be also public and it would be players. Third one const would be variable. Next const would be is complete, and the final const would be claimed. Now we will be defining the constructor, and here we will be assigning the manager, which would be equal to message.sender. Then we will be making the value of is complete to be false, and finally we will be also making the value of claim to be false. Now we will be writing the modifiers required. So first we will be writing the restricted modifier, and here we will be checking that if message.sender is equal to the manager address. Now we will be writing the function required. So the first function would be getting the manager. So we will simply write the function as get, and data type would be public. View returns with the address, and we will be simply returning the manager. Now we will be writing the function as get winner. Also here we will be keeping as public view returns, and we will be passing address, and also here we will be returning the winner. Now we will be writing the function status with public view returns and the address, and we'll be simply returning as is complete. Here we simply need to write the data type as bool. Now we will be writing the function for enter. We'll make it as public and payable. Now we will be writing the condition for require with message dot value greater than equal to 0.000 ether, and now we will be simply writing making the require of is not complete, and finally we will be pushing it into the player. Here message.sender. Similarly we will be writing the function for the pick winner. So it would be like function pick winner public restricted. Here we will be writing as players dot length greater than 0. Similarly we will be writing the require with not of is complete. Now we will be assigning the value of winner, which would be like players of random number players dot length, and finally we will be setting the value of is complete equal to true. So now we will be writing the required random number function. So function random number, it would be private view returns and uint, and it would return as uint of the algo kk. 256, and here it would be like ABI dot encode packed, and we'll be passing the block that prevent pre-random, the block timestamp, the player's length. Now we will be writing the claim price function, and we'll write the data type to be the public restricted, and we'll write the condition as players dot length should greater than 0. We'll write the condition as now require is complete. Also we will be writing winner dot transfer and address of this balance, and we will finally assigning the value of claimed equal to true, and finally we will be writing the function get players. We'll give it public view returns. We'll be passing address payable memory, and finally we will be returning the players. So here we have successfully written the contract required. So now once again we will go through the code explanation. So first we define the variable const variable called manager. So it is the address of the lottery manager, which is like contract deployer. Then we next define the players constant, which is the array of addresses who have entered the lottery. Next we write the winner, so which is the address of the selected winner. So next we write the is complete constant, which is the boolean indicating if the lottery rounded is finished. Next one is claimed, so which is the boolean indicating if the price has been claimed. Next we define few of the functions required. So the first one is enter function. So the enter function allows user to enter the lottery by sending at least 0.4 times 01 RBTC. It also checks that the lottery is still active or not complete. It also adds the player address to the player's array. So next function is like pick winner. So it does functionality of manager with only function to randomly select a winner, and then it also uses blockchain based randomness for a fair selection, and it also marks the lottery as complete. The next one is like claim price. So the claim price function allows the winner to claim the price. It also transfers the entire contract balance to the winner. It also marks the price as claimed. The next function is get players. So it returns the list of all the players who have entered the lottery. So the next function is random winner. So it is the internal function that generates pseudo random numbers using blockchain data, which combines block.prev_random timestamp and the player count for the randomness. So now we will be compiling our contract. So in the sidebar of the remix, you need to click on the Solidity compiler icon. So here we need to simply select the Solidity version as 0.8.0. So now automatically as we selected the auto compile, so we simply as our contract is we have a randomly select auto compile. So once we select the version of the compiler, it will automatically compile our contract. So as you can see, there is a green check mark on the sidebar of the remix, which means our contract has successfully compiled. So if you don't select the option of auto compile, you manually need to click on the compile lottery button. So it generates the ABI for our contract. So you need to copy the ABI. So here we will be copying it onto the blank page. So here I will be pasting our ABI, which we'll be needing for integrating with the front end. Now we will be simply deploying our contract. So we need to click on the deploy and run transaction tab in the remix. Now here we need to select the environment as injected provider, and as you can see, like it's automatically took the custom 31 network, which is the for Rootstock testnet. And now simply we need to choose the lottery from the contract section and hit on the deploy button. Now we need to confirm the transaction. So now our contract is getting deployed. So you can simply see it like it is on the pending state contract deployment. If you want to speed up, you can simply click on the speed up and need to pay a few fee for the same. So as you can see, like our contract deployment has got success. We can also view it on the block explorer. So here you got the transaction hash, the status, the value, the gas fee used, and every other thing. So once compiled, you can see your contract address and here it has successfully written. So you will be needed the contract address. So under the deployed contract section, you need to copy the contract address. Also, I will be pasting the same into the blank dot page. Here you can play with all the functions and the variables that we got. So congratulations, like you have successfully compiled and deployed the lottery smart contract on the Rootstock testnet. You can also interact with your deployed contract. So like first one is like enter. So when I hit on the enter, I need to send the transaction. Need to confirm my transaction. So function enter purpose is like it join the lottery by sending RBTC. So our transaction is getting confirmed. So which will add the player address to the player array, and eventually it would be increasing the contract address. Similarly, like you can view the players by get player function. So here you can see all the players entered into our lottery. Then using pick winner, you can randomly select a winner from the entire player, and from the claim prize, winner can claim the entire prize pool. By using the status, it checks whether the lottery is complete or not. It says false as we haven't done anything as of now. From get winner, you can see the wallet address for the winner, and from get manager, we can view the manager address. So in this video, you have successfully compiled your smart contract on the Rootstock testnet. So in the next video, we will be integrating our contract with the front end and see it on using interactive UI. So if you face any kind of doubt, you can simply navigate to the Rootstock website or join the Rootstock Discord from the link available at Rootstock footer section, and ask your doubt under the respective channel. Also, Rootstock have their own AI chatbot, so you can ask your doubt over here and get your doubt cleared in real time. So here I will be like testing like what is Rootstock. So it answers to all my question in real time. So in this video, we successfully deployed the contract. So in the next video, we will be integrating the front end with the deployed contract, and also we will be playing with the lottery system. Thank you everyone. Happy coding.